Hello students, in this video we are going to revise the concept of slope of a line and generalize this concept of slope of a line to a slope of a quadratic function. Let us begin. You are already familiar with the slope of a line concept. So in particular, if you want to talk about the slope of a line, then you will talk about slope of a line in terms of slope is equal to rise by run. So rise, this is in the y direction, and this particular thing run is in the x direction. So rise happens here and a run happens here. Okay, so given any 2 points on the line x1 y1 and x2 y2, if I want to talk about the slope of a line, the formula simply reduces to y2 minus y1 upon x2 minus x1. We are all familiar with this. We have already seen the representation of line in terms of slope. This slope actually denotes the sensitivity of the expression with respect to the change in x direction. So this slope actually denotes the sensitivity in the sense how small change in x affects the change in y. So if I change a small amount in x, will it affect significantly in change in y? Therefore, this particular term actually said to measure rate of change. So I can use different notation. For example, this thing we can write as delta y, which is change in y, upon delta x. So for delta x change in y, there will be a delta y change in y direction. This is what it means. Now when we measure the rate of change, when I am talking about a straight line, there is no change in the rate of change. That is, the rate of change is constant. If you are talking about a straight line, is constant in a straight line. And this fact in particular, we used rate of change is constant on a straight line, which is the fact that we have used for deriving the equation of a line, and we actually derived the equation of line for a non-vertical line where the slope is properly defined as mx plus bc. So this is the equation of a non-vertical line. You can also rewrite this expression in the form of functions, which we have also studied. So fx is equal to mx plus b. Now our goal, so this in particular is called a linear function. Now if I want to generalize the theory of slope, why do I need to generalize the theory of slope? First question. I want to generalize the theory of slope in order to be able to handle the concept of rate of change for all the functions. So what is the rate of change of this function? That's what. So in case of straight line, it is a constant. So there are no brainers. But let us understand this notion in terms of functions. So this fx is a linear function, and this is the graph of a function y is equal to mx plus c or mx plus b. Right? Now I want to understand the concept of slope, and suppose right now it is constant, but suppose had it been a variable, the slope had been a variable, how would I have encountered this? So if I want to determine the slope at this point, which is say x naught y naught, what I would have done is I would have projected this point on x-axis over here. It is x naught. Then I can take a small interval, a tiny interval of size h over here. So this point will be x naught plus h, and I can also go behind h units, which is x naught minus h. And what I would have done is I would have projected this point over here. This is x naught minus h and this is x naught plus h. Okay, so slightly shaky diagram, but you understand the point. So x naught plus h and x naught minus h, and then what is a change from this point to this point? That is what I would have calculated. So let us try to formalize this in the language of functions. So this is fx. So if the point corresponding point is f of x naught minus h, then I can write the point as f of x naught minus h is the point, and on x-axis that point is x naught minus h. So this is one point, and then I have another point which is x naught plus h and f of x naught plus h. So these are the 2 points which are typically denoted here in the green color like this. And I want to calculate the slope around this point x naught. So I have taken a symmetric distance x naught plus h and x naught minus h, and then I will go about deriving the slope using my formula, which is rise by run formula. Okay, so let us derive it. So there are 2 points, x naught minus h and x naught plus h, and f of x naught plus h and f of x naught minus h are the images of those points. So what is y? y2 minus y1. So f of x naught plus h minus f of x naught minus h upon x naught plus h minus x naught minus h. So this will be my slope. Correct. Now at what point I am calculating? This is my slope. Because my center is x naught, I am calculating the slope at point x is equal to x naught. Okay, so let me put it properly in the framework. So this is my definition of slope, rise by run formula, and now fx is this. So I can simply use this definition of fx and substitute it here. Let me do it on the next line so that it will be less cluttered. So here is the formula, and let me do it here with the different ink. So what is f of x naught plus h? In this function fx, I will put f of x naught plus h. So this will be m times x naught plus h plus b minus m times, we will put a square bracket here in order to avoid confusion, x naught minus h plus b. So this is the first point, f of x naught plus h. This is the second point, f of x naught minus h. Fine. Upon x naught minus x naught will get cancelled. H plus h I will get, sorry, this is ink to shape form. So this will give me 2h in the denominator. Yeah. So this is 2h. Now this is in fact going to be equal to, so m times x naught minus m times x naught. So for clarity I will rewrite one more step so that there won't be any confusion. So this is m times x naught plus m times h plus b minus m times x naught minus minus will become plus, plus m times h plus b will become minus b upon 2h. Now as you can readily see, this m times x naught cancels with this m times x naught, b cancels with b, and I am left with mh and mh. So together they will contribute to 2 times mh. So that will give me 2h times m upon 2h, and then 2h, because h is greater than 0, will cancel itself off, and I will get the answer to be m, which is expected because I am dealing with a straight line. So the slope of a line at x naught is m. We already know, and we also know that the rate of change of a line is always constant. So therefore my slope will always be m, and now we have verified this using rise by run formula. So our formula looks more sophisticated and more robust, so we can use this particular formulations to figure out the slope of a quadratic function. So let us jump into slope of a quadratic function. So here is a quadratic function, y is equal to x square, that is given to you, and I want to figure out the slope of this quadratic function at some point. Let us say at point x naught, y naught, right? So I will naturally use my similar strategy. I will project this point on x axis. This is a point x naught. I will go h time units, h units on this side and h units on the other side. So this point will be x naught plus h, and this point will be x naught minus h, right? So this is the point, and then I will consider the corresponding point over here and the corresponding point over here on that line. So it will be here. Let us erase this line, it is not needed. So this is the point that corresponds to x naught plus h, and this is the point that corresponds to x naught minus h, and I will use f of x naught definition. Now this definition is so robust that it doesn't distinguish between which x naught we are taking. So we can simply write, for any x naught I can write slope at x naught, because what is slope? Slope is actually calculation of rate of change. Slope at a point x is equal to x naught is rise by run, and that will be given by f of x naught plus h minus f of x naught minus h upon the horizontal length that you have traveled is 2h. So this will be 2h. Clear? Now let us bring in the function itself, y is equal to x square, and see what is the slope of this particular function. So simply put in y is equal to x square, and therefore this will be f of x naught. So it will be x naught plus h the whole square minus x naught minus h the whole square upon 2h. Now you can simply do the calculation. This is again a quadratic equation, so you can simply write x naught square plus h square plus 2h times x naught minus, again to be precise I will put the brackets intact, x naught square plus h square minus 2h times x naught, correct, upon 2h. Everything is intact. Now the cancellation job, so I will cancel x naught from x naught, h square both are cancelled. I am left with 2hx naught minus minus plus 2hx naught. So I will get here, this is going to be equal to 4 times hx naught upon 2h. H is not equal to 0, and therefore I can cancel this off, and I will get a factor of 2 here. So I will get the answer to be equal to 2x naught. So what is the slope at any point x naught? Slope on this curve at any point x naught, it is 2x naught. The answer is 2x naught. So in particular you can see this is nothing but another function gx, which is equal to 2x, and this is the slope of this particular quadratic function. Let us now generalize this concept to any quadratic function. So let us all the standard assumptions kick in, and let fx be defined in this manner. Fx is equal to ax square plus bx plus c. In order to ensure that this is a quadratic function, I will put the condition a is not equal to 0. Because a is not equal to 0, let us go ahead and calculate this. If a is equal to 0, we have already calculated because it's equation of a straight line, and you know the slope is constant and the slope will be b. Now let us see how to calculate slope of a equation, slope of this particular function. Again, use the same logic for any point x naught. Any x naught, I have defined the slope as f of x naught plus h minus f of x naught minus h upon 2h. This is slope at point x is equal to x naught. Go ahead and do a similar calculation by just substituting this function. So it is a times x naught plus h square plus b times x naught plus h plus c minus, let me put a square bracket here, a times x naught minus h the whole square plus b times x naught minus h plus c, and square bracket is complete, the whole thing upon 2h. Correct. Let us simplify one by one. Slightly shrink it down so that it is visible. So let us first focus on these terms like a. So let us club them together, and you will get something like a times x naught plus h the whole square minus x naught minus h the whole square plus b times, that is the second term I am clubbing in, this and this, which will give me x naught plus h minus x naught minus h, and plus c minus c, so c will cancel itself off, so I don't have to worry about that term, upon 2 times h. This will again give me some idea. Now you can redo this calculation, or you can use the calculation I have done in the previous example. So we had x naught plus h the whole square minus x naught plus h the whole square, this particular calculation, and we showed that it was coming out to be 4h times x naught. So I will simply use that calculation and substitute it here. So a into 4h times x naught plus, so a, this is complete, plus b times x naught plus h, so x naught minus x naught will cancel itself, h plus h, that is 2h, so I will get b times 2h upon 2h. So on further simplification, you can simply take out 2h as a common factor upon 2h, and here you will be left with 2 times a x naught plus b. Yes, and this 2h will cancel itself off, and therefore my answer to the question that what is a slope of a general quadratic function is 2a x naught plus b for at any point x is equal to x naught. So I can rewrite this as some function gx which is equal to 2ax plus b. So we have figured out one formulation, which is if fx is equal to ax square plus bx plus c, that is a quadratic equation where a is not equal to 0, then if fx is this, then gx, which is nothing but slope at x, which is, you can write this as slope at a point x, is 2ax plus b. So this is the characterization of the slope. Now you can see the salient features of this slope. What is a slope? Slope, as we mentioned in straight line case, is rate of change. So if so now you can ask a question, rate of change is equal to slope at any point if something happens and this slope at that point x is equal to 0, then what is a consequence of that? So this is an interesting question and we will try to answer this question. So let us say gx in this case is equal to 0 for some x. So what is that x? You can check it. That means this 2ax plus b is equal to 0, which essentially means what you have got is x is equal to minus b by 2a. If you are unsure of the calculation, let me do it for you. 2ax is equal to b. A is not equal to 0. This is the assumption. Therefore, 2ax is equal to minus b. X is equal to minus b by 2a. Okay, so this is how I got this number minus b by 2a. Now you note this number is nothing but a vertex of the parabola. This number is nothing but vertex of the parabola. That means this is the number at which the function, the quadratic function, assumes minimum or maximum. So this is an important application, and you can easily you can give a physical interpretation of this as, because the rate of change is coming to 0, because the rate of change is coming to 0, the rate of change prior to this might be positive and now it is going to become negative. That means the rate of change is changing and therefore the slope 0 is going to be the minimum or maximum of the original function f. This is an interesting application and it comes when you study calculus. So points of maxima and minima can be easily derived using the expression for the slope. That's all about slope of a quadratic function. Thank you.